Hey YouTube, it's Dimitri, and today we're on time series video 15, I believe. The last two, we downloaded some weather data, did some data exploration. In this video, we're going to continue the data exploration, but let's just dive on in. Okay, so to start off with here, let's just clear our console. We're going to run all of this code from the last few videos here. So let's just highlight it and run it. Okay, and now we're going to have this chart here on the bottom right. That is where we ended. The red is going to be the maximum temperature here, and the blue is going to be the minimum temperature for each day. So let's just start here and say, this is going to be video time series 15, episode 15, and this is going to be data exploration part 2. All right, so we have quite a bit to cover today, so I'm going to try to go quickly. Bear with me here at the beginning. We're going to have quite a bit of kind of like theory and understanding, but this is crucial and important for model development. I cannot emphasize this enough. Too many videos just show you code, you copy, paste, and you don't think things through. And then in the real world, things blow up because you don't understand the theory. So let's just dive on in here. First off, let's analyze this data, which we talked a little bit about last time. If you look at the data, right, it has a clear annual pattern, which makes sense from what we expect. You're going to have a peak sometime in the middle of the summer. You're going to have the lowest point sometime in the middle of the winter. This is an annual occurrence. Date-wise, there's 365 days in most years. If you have a leap year, it's 366. But in general, we have this. It's also important to note here that we have oscillation within the data itself. So while the overall pattern is clear, there's going to be small oscillations, which we're going to look at in more detail here in a second. Okay, and then looking at this now from a modeling standpoint, we know our goal. I haven't really told you guys yet, but the goal is going to be to model the minimum temperature. We could do the maximum temperature if you want. I'll leave that to you guys for a fun exercise to do to see how it compares. But in general, we're going to look at three types of, we're going to call them models. But realistically, we're going to have a non-stats model. So this would be like business analytics. We're going to do a stats model. So this would be a statistician. This will also be like risk management, something like that, or a quant. And then we're also going to do, we're just going to call it data science. But realistically, we are going to do a neural network. Okay, so we're going to do these three approaches. We're going to build models for them throughout the video series, not all in today. But we're going to just talk about the pros, the cons, when they work, when they're better. So I want you to take away from this video and all of the videos, no method, no field of study is the best. Everything has its pros and cons. In some scenarios, you'll see that business analytics using simple logical approaches with data is far better than building stats models or data science models. Other cases, stats models have great intuition and meaning and theory behind them, and they're the best. In other times, things might be a little more complicated and you might be able to use a data science approach. But let's just dive into more of what we're actually going to be doing here by analyzing this data further. So in the last video, I forgot to check for Anaise. So let's do that here quickly. One way to do this is just going to be we're going to call a variable NA_check. And you just type in is.na and you put in the data. So we're going to do airport and we're going to run this. If you want to view this, you can. So you get an idea of what we're doing here. It creates these columns and it says false if that value is present. It would say true if it's NA or missing here, right? But the issue is when you scroll, right, there's a lot of data. What I want to say here, though, is, don't depend on the eyeball test. So just looking at this is kind of risky and dangerous because there's so much data. So what we're going to do here is going to create something called unique. And this will tell you if there's the unique values in the different columns or in the data set. And we're going to type in NA_check. And we're going to run this. And it's going to tell us false for date, false for Tmax, and false for Tmin. So what this means is the unique values in the date column, they're all false. The unique values in the max column and the min column, again, all false. If even just one of them were true, you would have another line underneath that would say true. So from this test here, we can say, okay, all values are false meaning no Anaise. Okay, so we're good to go on there. I should have done that earlier, but we're getting that done now. And the next important point here is that when you build a model or a non-model or a data science approach, whatever you want to call these algorithms or whatever, you need to split your data. And what I mean by this is you need to have some sort of like I don't know, we'll call it a training or like a development data set. And we need to compare that. So we'll do versus. Something else is like out of time. We'll call it testing maybe, something like that. But you need to be able to build a model on something, and then to prevent overfitting, yes, this occurs in statistics just as much as it can occur in data science or even non-modeled approaches, right? The business analytics approach. You can have issues with this. So you need to build on one set of data, and then you need to compare it to another set of data. What we're going to do here, and I hate that I have to say this, but it's time series data, and almost all data in general comes in through time. So you need to split this based on time. I'm just going to make a note here, though, for we're going to call it our stats and non-stats approaches. We're going to do a 50-50 split. And what this means is that we're going to have, so in stats, you typically call it development data. Your dev data is going to be, so we have 10 years of data from 2010 to 2019. You include 2010, it makes 10 years. We're going to do 2010 through 2014. And this is going to be our dev sample, and this is going to be 50%. And then we're going to have, we'll call it out of time. And out of time is going to be from 2015 to 2019. So again, another 5 years, and that's going to be the other 50%. For the neural nets, what we're going to do here is we actually need 3 types of data. The reason being here, so let me just make a note. In neural nets and in types of model structures where you don't just build a model and then test it. In neural networks, you have to build a model and then you have to train or tune or fine tune, whatever you want to call the hyperparameters. So you need to fine tune hyperparameters. And this is going to be realistically be like the model structure. And I'm going to note here too, you can also do this for stats and non-stats. It might even be better practice to do this. But in general, for these neural nets, what ends up happening is you pick your variables, for example, and you run it through a neural network. And then you realize, right, maybe I need more layers, maybe I need more neurons, maybe I need less neurons, maybe I need a different learning rate. These are considered your hyperparameters. So like layers, number of neurons, learning rates, things like that. You're going to fine tune that. And what ends up happening is you start off with a training data set and you're going to build the model and you're going to say, okay, it's not very good. So I'm going to actually do, we'll call it a validation data set here. For the validation data set, now we're going to fine tune the model based on the training results we've gotten. And we're going to change the hyperparameters here. So we're going to adjust those. And then we're going to go back to training, and we're going to retrain, and we're going to do validation. What this actually results in a lot of times is what we call information leakage. So if you were only to use these two, validation and training, information from training is going to get leaked into your validation. And so your validation will fit much better than if you were to have a final testing data which has never seen the validation or training process here. So information leakage occurs when information is basically discovered by the modeling process. So it happens, it's an issue. You need to have 3, especially for neural networks. For this, we're going to do 2010 to 2014. So this will again be 50% of the data. For validation, though, I'm going to do 2015 to 2016. This will be 20% of the data. And then for your final testing, I'm going to do 2017 to 2019, which is going to be 30% of the data. You can choose your splits however you want. For developing models, though, you need as much data as possible. You might even go more than 50%. Again, this is an arbitrary decision. You might adjust and figure out how much data you really need to make this. Given this is cyclical, I want the development or the training set here to be the largest. So you could even make it larger, to maybe do 60% and then do 20 and 20 for validation and testing. Again, I also think that the testing component, so seeing data you've never seen, is a very, very important and crucial part of the testing of a model, its robustness. So I would like to have a little bit more data here than I would in the validation set. Now again, you could argue this, you could have different theories, different perspectives. Like I said, you can change the percentages. It's up to you, but be able to justify and argue with someone on why this has occurred and why you chose the percentages you did. Just like I gave you a few examples of reasons on why you would do that. Okay, so we're going to start off with here, though, the stats and non-stats method here. So stats, non-stats, data creation. So all we're going to do here is we're going to create one called dev. And we're going to take our airport data and we're going to say which date. So do airport and then do date is less than 2015 0101. And then don't forget to put the comma here. So remember the comma separates the rows on the left-hand side of it and then the columns on the right. We're going to go through the rows here of the airport data, look at the dates, anything less than 2015 January 1st. So we're not going to include that. Will end up being 2010 to 2014. We can run that, and just to kind of do a quick view and a quick check here for good practice, let's just run it and see. Okay, 2010 January 1st is the first one. You can see they're in order, right? It goes day 1, 2, 3, 4, 5 in January 2010. Scroll to the bottom, and the last data point is 2014 12/31. So our logic is correct. So we'll keep going with this, and then we won't have to check the other data points here. So let's create our out of time. We're going to do the exact same thing here. Okay, so I'm just going to copy what we already had from our development set. And then what you'll want to change here is just the date, because I want the other half. And I also want to change, instead of less than, I want to have greater than. But if you left the code like this, you'd exclude January 1st, 2015. So we'll change this back to December 31st of 2014. We'll run that. Remember, we did a 50-50 split. So to quickly check the quality here, out of time is 1826. Should be the exact same number of observations as dev, and it is. So that's good. That works. We're good to go on the stat side. Okay, so now for the neural nets data creation, let's just do this simple. So training data, which is going to be what we're going to start with. This is the exact same as the development data set that we used in the stats one, right? 2010 to 2014. Run that. You can see up here that training has the same number of observations as dev. And again, same number of variables. Next, we're going to create the validation sample. And this one's going to be a little bit more complicated. So it's airport. And then again, it's going to be which. And then we're going to do airport date, just like we did before. And we're going to say if the date is greater than 2014 12/31. Add these single quotations. But we also want an and. So you have to put an ampersand, which is the and sign. I don't believe you can type and, but use the ampersand. And then we're going to do airport date is going to be less than 2017 0101. So what we're saying here is we want to take the data based on the dates that is going to be greater than 2014 12/31. So we're going to start January 1st 2015, and we're going to go through the end of 2016 because we're not going to include January 1st 2017. So greater than this date, less than this date. That'll give us the range that we want and we need. Again, don't forget the comma. I say that because I forget it constantly. And we'll run that real quick, and you'll have your validation set. And then testing will be an easier one. So we'll just copy and paste up here, like our out of time sample. Paste it down here. But the dates are going to be different. So we're going to want to put in 2016 12/31. So what this is going to give us is going to be 2017 onward. So if it's greater than the last day of 2016, so that will give us 2017 to 2019. Run that. And a quick mental check here. Again, I can't emphasize this enough. When you're coding, look and see and make sure what you typed and what it did is the same, especially when you're new. If you do this a lot more and you're a lot more experienced, you don't have to check as much. But we should know that training should be 50%, validation's 20, testing is 30. So from largest to smallest, it should be training, testing, val. If you go over here, training is 1826, testing is 1095, and validation is 731. So that makes sense, and it matches. If you really want, you can open the data and look at it. You can see the dates actually correspond to the information we listed up here. Okay, and now we're gonna just kind of look at we're gonna call them properties of the data, and we're gonna run into a few issues here because I've looked and seen. We're gonna understand the data better though. That's the whole purpose of looking at this, right? We don't want to put our head in the sand and pretend it doesn't exist. One thing I'm going to state here, which I would like to tell everybody in multiple videos, is let the data talk to you. You don't tell the data what you think. Okay, this is probably the biggest takeaway from the whole video. I constantly see in practice, in industry, in academia, people look at data and they say, oh, it's, let's say this case is weather data, it's time series data. I'm going to use this type of model. And then they go and they build that model. My question to them is, how do you even know what type of model to build? Right? Why would you just pick something? This makes completely no sense. Like you've lost your mind. I can't stress this enough. We're going to discover the data. We're going to listen to the data. The data is going to tell us different secrets about itself, right? Is it stationary, not stationary? Where is it not stationary? Are there autocorrelation functions, right? So is it serially correlated? Do we need to add in, ACF and PACF testing? And we're going to do that. But do we need to add in, an AR term or an MA term? Should we go the ARIMA route? Are there long-term or short-term equilibriums? So should we do ARIMA? Should we do a vector autoregression model or an ECM type model, right? There's all these questions you have, but you don't know because you're not as smart as your data. So just listen to the data because the data will tell you what you need to do. So let's just start off with here. We need to install a few packages. So for stationarity testing, I like to use the ATSA library. So we'll run that. It'll say it's built under a different version. You can ignore that for now. And then also we're going to want to do ACF and PACF testing. So we're not going to build any models yet. I'm just listening to the data and trying to learn a little bit more about it. It will help me make business logical explanations as I do the model development process. But for this one, I like the ASTSA package, and you can run that one. And now those are installed. So we're going to look at stationarity of the entire data set here. But we need to figure out what type of data is this. Is it type 1, type 2, type 3? Remember, type 1 means zero, mean, white noise, random walk, essentially. So that would be data that's bouncing around the zero line. Is that our case here? No. The mean here is going to be 60 something-ish. So no, this isn't going to be a type 1. Type 2 is going to be what we call single mean. Single mean is going to mean that you have something like, say, 60 is the mean, and the data is going to bounce around 60. Yes, that looks like it's the case here. The third type is going to be type 3. This is going to be trend data, which is going to be data that's trending across time. Do I see a clear upward or downward trend? No, so this is going to be type 2. So when we run these tests, we're only going to look at type 2. And we're going to see some issues in the data. We're going to see some theoretical constructs we're going to cover later. So right now, I'm just testing to get a mental image of what's happening, keep it in the back of my mind, and in later videos, we'll utilize that. So you do stationarity test here, and we're going to test. I was going to do both of these. You can do both if you want. I'm just going to do team N because we're going to end up just modeling that. And then you want to put in the number of lags. So please specify the number of lags. Don't just let the computer do it at once. So if you did 30, which is going to be one idea here, that's just going to be 1 month. The issue with this, though, at 30 is that you're going to have a trend component if you snapshot these into 30 days. We're trying to model multiple years, and you need to think about this from a logical perspective of cyclicality. 30 days is not going to be enough, but let's just run it and see. I'm almost guaranteeing you will not have stationarity. Okay, so again, we scroll up. You see it's type 3. It's not type 3. Scroll up. Okay, type 2, which is going to say with drift, no trend. Okay, it looks, if you want the p-value to be here, let's just put a note. You want the p-value to be less than 0.05. So 5% confidence interval here, or 5% confidence. We're going to scroll, and then all of a sudden we have a failure here at, 13, 14, 15, 17, and we see all these issues, and it just fails towards the end of the month. This probably isn't the best thing to look at. I'll encourage you guys to run this. And you do dev, tmin, in lag. So I'm going to do 360. I believe it caps out at a much smaller number. And I'll run this real quick, but it will take you some time when you run this because this is a lot of lags. Okay, so it's been a few minutes here, and it maxes out at 333, which I believe is 332 lags. So 27 are admitted. That's fine. Again, ignore all the different types, but scroll to your type, which is going to be type 2. So that's type 3. Okay, so we're going to look at type 2. Again, this is going to have the same process we had before, where it should fail, again, around 13. It's the exact same test, but we want to scroll to the end of it. So you see in the middle here, we do have randomness. We do have good stability within lots of different periods. But you'll notice here, when we get towards the end, right, we're going to have issues with this. And one of the reasons for this is going to be an AR1 process, which I can tell you right off the bat. Or at least you have a cyclical component, meaning that the peak from one period to the peak of the next period are going to have issues. Because essentially they're going to be the same almost every year. They're predictable, which is good. So stationary processes are going to be predictable. But again, this might be an AR1 process. It might not be necessarily stationary at different levels. And we're going to explore this later. So for now, we're just going to put a note and put not stationary. For those of you that know me, right, this is an issue. This is a big issue, and we're going to have to address this through modeling and modeling structures. But for now, we're going to remember that it has cyclical components. It might not be so stationary, though. And again, if you would like, you can also test Tmax for additional practice. And then we're going to do the ADF test. So we're going to do ACF, autocorrelation function. All right, so we're going to do the ACF test here, which is the autocorrelation function. We're going to do ACF2 function, and we're going to put in dev, and we're going to put in tmin. This will give us the ACF and PACF. So autocorrelation function, partial autocorrelation function. If you're interested in what these are, how to read them, please go back to earlier videos in these time series videos that we've done. I have specific videos on the math and the testing and what they mean and how to read them. But you'll see here for tmin, we have a really, really high autocorrelation function. The ACF is almost like, 90%, 95%, something like that. The partial autocorrelation function, it looks like it fails tremendously as well. So remember the little dotted blue lines, that shows you what is, meaning there's no autocorrelation, there's no partial autocorrelation. We don't want that in the data because this is a feature that we're seeing. We see that it is serially correlated. So serial correlation exists. This makes 100% sense, and we expect this. There's nothing wrong with this. Right, we expect that the weather today will be similar to tomorrow and that yesterday was similar to today. They will be correlated across time, but we need to explicitly model this, okay? And again, you can do Tmax if you want as well. But as I mentioned, data looks different depending where you zoom in. So these charts are pretty high level. Zooming in on granularity is one approach. So if you go from looking at daily data to hourly data, for example, the patterns and trends might be vastly different. This is a feature in a stochastic processes. But just from a charting perspective here, it's hard to see different patterns or trends within the big macro trend. So let's take a 30-day look at some data here. And we're going to call this Snapshot Zoom. You can name it whatever you want, but that's what I'm naming it. We're going to take the development data set. And we're going to take the first 1 to 30, we'll do 31 rows here. and we'll put a comma, and we're gonna look at all of them. So we're gonna create that, which I'll run here in a sec. And then we're gonna just basically plot these out. I'll mention too, I'll put a textbook link below on plotting inside of R. There's a book I really like, and it uses the ggplot and the geomes and talks more about the theory, but you see how to do a lot of this plotting if you're interested. But we're gonna do ggplot, and then we're gonna do the geom. We want a line chart, and we want the AES to be, okay, so our X is going to be Snapshot Zoom. We're gonna use the date. And then for Y, we're going to do Snapshot Zoom, and we're gonna do tmin. That's what we're trying to plot here. And then outside of this parentheses, you put a comma, and we're gonna type in the color we want. We want blue, so we'll stay consistent with the other chart. But I also wanna add the red line. So put plus, and then we're gonna do the same thing as above, which I'll just copy and paste this for simplicity. And what we're gonna want is geom lines, AES, snapshot. We want the date to be the x-axis, but we also want, let's just do the max value so we can see it, and we want it to be in red. So we're gonna make this chart on the right, but it's gonna be zoomed in, and it's only gonna be on the first 30, 31 days here. All right, so we're gonna highlight this. Make sure you select your data up here, and we're gonna run it. Okay, and here's a zoomed in snapshot. It looks very different than this big one. So here's the big chart. This is just the first 31 days here of 2010. It looks kind of like everything's going down or something like that. It's hard to see. When you zoom in, you're like, oh, there's a different pattern here, something different to look at. But again, we want to have, we want a better view here. And what I mean by this is we want a better understanding of our data, right? Does it all look like this? Does it all have kind of like a cyclical bounce? If it does, maybe we can model that. But let's figure out how do we just do this, and we're going to do this with a loop. So we're going to loop the charts, and we're going to look at random snapshots. So to do this, we're going to do a for loop, and we're going to do it from I in sequence. So the reason we're using sequence is I want to pull different, so I want to skip. I don't want to view the first 30 days, the second 30 days, the third. I want to view like 30 days, then skip like 100 days, and then take another snapshot of 30 days, and then do another snapshot. To do this, we're going to start at 1. We're going to go to 1800. So if you look at your data over here, it's 1826 is the total. It's not divisible by 30, so we're just going to shorten it a little bit so that we make sure we have some fudge space at the end. You could pick less, you could do it a little differently if you wanted, it's up to you. But we're going to do it by snapshots of 100. So we're going to skip every 100 after we take the snapshot, so 100 days. Put a curly bracket, and what do you want to do inside this loop from 1 to 1800 basically, and skipping by 100. I want to create something called J right now, and so we're going to do I plus 30. So the beginning value, like in this, is 1, and I want to add 30 to it, so I get 1 to 31. Then when I skip by 100, I is going to change to 101. So now I want to do 101 to 131. So J will now be 131. So this is just used to track the window that we're going to be doing, and we're going to be plotting out. And then you can actually just copy up here the snapshot zoom. But the difference is here is we're going to change the numbers, like I said, from to I into J. And then next we're going to type in chart. So we need to create an object. And for this chart, I want the exact same code as up here. So I want to take this chart that we created with ggplot, and I want to have the blue line be the minimum and the red line be the maximum. And then after I do all this, what I want it to do, I want it to print out this chart. So we'll call it chart, we'll print it. Okay. And then we end it with a curly bracket down here, and we should be good. So let's plot this out real quick. So we already ran the code above, so let's run this. And give it a sec, 'cause it's got to produce a bunch of charts. Okay, so here's one chart. It's September 1st to September, I don't know, 25th. If you move back, it's like, okay, we have May through June. right? February to March, they're all different years though. And I don't really care about the years, but you could have labeled them if you wanted. But I just want to show you the trends, the patterns are all very different. So we're not seeing something that's very easy to model at a daily value. We'll go into this later. The mins and maxes though do have good shape consistency, which is kind of interesting. And I guess it makes sense. Again, serially correlated rise. If a day is really warm, the cooler period should be similar. But you can scroll through these and look. Now, for more of a visual understanding of what we're doing, I'm going to create some code here. I'm going to type it out. I'm going to kind of breeze through this quickly. If you want, you can break it down and try to understand it better. But what I want to do is just show you how these little charts relate to this big chart in a little clearer way. So we're going to create something called start, and this is going to be a date. So as date, as character, and we're going to do 2010 01 01. And then we're going to close this bracket. We're going to create an end date. It's going to be the same. Mess that up. Okay. As character. And for the end date, I'm going to want 2014 11 13. So these dates are a little different because when you run the snapshots, which I'm going to show you here, you don't want to run to the last date because you're going to run out of data. You'll be trying to plot something that doesn't exist. So I just scooted back a little more. And then we're going to create something called gray coordinates. So gray chord. This is going to define when we snapshot, take the snapshots, the beginnings of them. And this is just going to be as date. And we're going to use sequence again here. So again, if you don't know what sequence is or how to use it or understand it, please go back to my other videos. I create them for a reason. It's not part of the time series one, but if you search through my our programming series, you'll find out how to use this more efficiently, but it's not too difficult. So we do start date, end date, and we're going to do by 100 as we did above. Okay. And then what we're going to want to do is just going to create some wonky variable name inside this data frame. I just like to rename it real quick. So col names, which is the column name, and we're going to use gray coordinates, and we want just the first column because there's only one, and we're going to rename that x1. Okay, and then we're going to create now the end of these snapshot windows. So st30, start date 30. I'm just going to copy and paste this for simplicity and ease. So rename these. And then we're going to change the dates to 31, which is what we added. And then this will be 12, 15. And then we'll create something similar to this. So it's going to be called gray coordinates. We'll just call it x2, so we don't need to rename it. As date, C sequence. Just copy and paste this in here. Okay, and it's going to be start 30, end 30. Okay, this should be fine. So what I'm doing is creating just boxes of starts and stops, which I'll show you in a sec. And then finally here, we're going to just do a ggplot. And again, we can just scroll up and take what we already did before. So paste that in there. But now what we're going to want to do is overlay, so do plus, and something different here, which I haven't gone over it, geom rectangle. And we're going to have the AES, it's going to be a little different. AES is going to be xmin, which is equal to gray coordinates, and it's going to be x1, and then x max. So these are the x coordinates for the rectangles we're going to draw. Gray coordinates x2, and then for y min, we're going to set it equal to 0 because our temperature never drops below 0 on here. And then we're going to have y max is going to be equal to 120, which should be above. Should be above what we're looking at here. And then finally here, we're going to do our alpha. So if you do web design, you know what alpha is. It's the transparency factor, 50% transparent, and we're going to close these out. And then finally, we're just going to print out P. So a few corrections here real quick. You'll see the data didn't plot correctly. One, I forgot to put the data frame in. So this needs to be a data frame, not a list. And then Snapshot Zoom, which I copied and pasted, it needs to be dev, the full data set for the development here. And we'll need to change that for both of these. Okay, so now we can run this. Okay, so I'm hoping what you see here is this is the mins and max data we plotted before. Each gray bar is where the snapshots came from. So the last snapshot here is this chart, and then the second gray window before it is that chart. So this is just to show you conceptually the gray bars are every 100 days where that 30, 31 day snapshot's coming from. Okay, and so we're just gonna wrap the video up here. So this is a conclusion here. The conclusion that we got from this video is, right, we removed Anaise. We are gonna use tmin as our modeling data. I just told you, but we'll do it later. We looked at, dividing your data, so splitting data into dev and we'll call it other, but I mean out of time, validation, or testing data sets. We talked about the importance of that. And then we did some properties here. So some properties testing, stationarity. We know that it's not stationary. And then finally, we did some serial correlation review, and we looked at the ACF and PACF charts. And as we expected, there is serial correlation in the data. It all makes sense. The next video, though, what we're going to do is we're going to create a non-model common sense approach here. We'll talk about that later, but what we're going to do is just look at day and month and use past day and month averages to create a model. So anyways, if you like this video, don't forget to like, share, and subscribe. And as always, until next time.